Welcome back to the lecture series on air pollution, sources, fundamentals of air pollution, sources, composition and its mitigation. Today's lecture will focus on very important topics in which aerosols are used to serve as a nutrient actually. So, this is very new topic and very emerging topic as well. So, in this lecture I will be and the subsequent lectures I will be covering basically that what are the key nutrients that are there in the aerosols and how they can impact on the ocean pH and then biogeochemistry. So, this is going to be a very interesting lecture. I would like this will be very basic for the undergraduate student, and then I will at the same time will focus on the more details about the future like masters and PhD students. Okay. So, as we know, I think by this time you have fair idea about what is aerosols and what is their composition, although I did not very explicitly mention the composition, but in the last couple of lectures I have discussed that what are the main key elements or composition of the dust aerosols, and this will be mostly focusing on the dust aerosol itself. So, this I hope that you have a very good idea. So, now how this actually serves? So, you have aerosols. These aerosols contains micronutrients, and these micronutrients, because these micronutrients are in the atmosphere. Now, these can either via wet deposition or dry deposition they can be deposited. Okay. Now, wet deposition means it needs kind of something water in some form, like either in the rainwater or as the precipitation, which could be actually like snow, okay, or drizzle or any kind of fog and other things that can be there actually. And dry deposition is actually just because of its mass and falling under the gravity of the earth. So, mg, the force that is acting on the particle of mass m will be m into g, and that this will be deposited. So, we will discuss that how these dry and wet depositions impact ocean biogeochemistry, and especially not only ocean biogeochemistry, they also impact all the aquatic bodies actually. Not only that, and then they actually also can impact the soil fertility. Okay. So, this is going to be very interesting topic, but let us see that what are actually. So, as it says that aerosols as nutrients, it happens through the deposition of particulate species. This is very important. So, because here we are actually all the things that we are deposition, micronutrient deposition we are talking about, we are talking mostly in the form of particulates, not in the gaseous form. Gaseous forms we will discuss later. And many places and especially some of the oceans, they are actually deficient in iron, phosphorus and nutrients. So, these are the three very key limiting nutrients that are needed. These nutrients, when they are deposited, they are key nutrients for phytoplanktons. Okay. Like zooplankton and phytoplankton and any other living organisms that are there, and other living organisms, because they actually are needed for the kind of photosynthesis or actually not photosynthesis. There are actually within the aquatic systems there are some elements, for example algae and fungi, they can be grown actually, especially in the rivers. And I think I do not have slides, but maybe I will in the next slide, next few lectures I will give an example of river Ganga, that how river Ganga becomes green because of the algae. Maybe I can just talk this right now, because it's by the way, this is not because of the wet deposition, it is because of the deposition of the nutrients during the very early phase of the rain. So, just give an example. When the rain in the initial period, what will happen? Just before the monsoon start, the atmosphere is loaded with high aerosol content. Okay, and these high aerosols, they contains lots of nutrients, and especially the first spell of rain. First couple spell of rain, it will remove many of these nutrients from the atmosphere. And suppose if the water is if the rain is that sufficient that it can be transported into the river, this river water or this water, that is surface water, they will be enriched in these nutrients. Okay, and when these are enriched in these nutrients, the river's biogeochemistry will change. And one of the limiting nutrients in the ocean, in the rivers, is actually nitrogen and phosphorus. So, this actually not is supplied from the surface water, will not contain the only thing that is actually from the rain plus aerosols. So, it is not only rain plus aerosol, it will also come, because the surface water, it will be leaching of soil. Wherever this water is going, it will try to leach the soil, and from the top soil it will take the nutrients, and because of that one, this becomes very important. And this nitrogen and phosphorus, they are very much needed for the algae to grow, for algal growth. So, this can be actually taken as an important source. There is actually very important mechanisms here that is involved. I think I am little bit going away from the current topic, but this is important actually, because this came into the context and I did not have the slides for that. So, let us discuss that one. What will happen? These aerosols are when these nutrients actually in the form of, basically in the form of nitrate or in the form of phosphate, they will be actually in this form. So, these are actually, what is that? They are all water soluble. Since they are water soluble, these species will be directly taken up by this algae, and once these algae take, so during the initial phase, these algae, they actually are like hungry. They are very hungry. They are hungry because they need lots of nutrients, and once they find these actually nutrients, they will try to grab as much as possible, and that time the algal growth will be very huge, and because the algal growth will be very huge, the water will look like greenish. Okay, at that time it is not suggested that you should drink, or even you do not go and take bath in those rivers, because these rivers, these algae contains toxic elements that can have your effect on your human health. So, that should not be there. So, because they are hungry, they will take lots of nutrients, and there will be huge algal growth, and the whole water will turn into greenish. Okay. Now, when this is greenish, then what will happen? It will look like algae formation. Now after some time, but only this thing is not important. Actually, for this to happen, you need also sunlight, and this happens basically, as I said that it happens during the first spell of rain. So, it is sometimes in May or early June. Okay. Mid to late May, you can say, whenever the rain comes, mid May to late early June, this phenomena will happen. But in order to, because algae will do photosynthesis, so when they will do photosynthesis, not only that, you need actually sunlight. So, sunlight If there is actually now you can imagine a situation, because May and June the sunlight is very adequate. So, sunlight is there, so there is no problem of sunlight. So, sunlight is already there, only problem was that the nutrient was limited. So, sunlight is there, nutrient came, algal bloom will be there. So, you can see I can share some of the slides in the probably in the coming slides. Okay. So, this is one thing, and so this is deposition of the nutrients I talked about. So, whether it could be by rain deposition directly into the ocean or over the rivers, or they can be transported as the nutrients during the surface water. Another this actually this is important here that I talked about. I do not know where is the. So, this is actually is the in the particulate form. Now, there are actually gases. These gases are stick species are produced, and these are either in the form of gas or in the form of vapor, liquid vapor. Okay. Okay. So, you have liquid vapor. What will happen? These gases are there, they will be on the sulfate surface of aerosols. These gases will be deposited. Okay. And especially because these are acidic, if this is actually basic, then acidic species very easily will get attached to this one. And when they get attached to this one, what will happen? You have a base here, you have a acid here, neutralization process will happen, and they will leave this nitrate and sulfate aerosols, because the hydrogen will go and water in the form of water it will be removed, it will be coming, or it will formation of water will be there, H2O will be formed. And these ions basically nitrate and which were actually binded in the form of either in the form of liquid or gas, they will be coming like nitrate and sulfate. So, you have nitrate and sulfate free in the ionic form, and they will be deposited on this and when this aerosol is deposited, they will be actually like now this will when these aerosols are deposited, then what will happen? They will be actually in the particulate form. So, they will be having the same effect as this one. But suppose these gases are directly through the air sea exchange. Okay? You have air sea exchange, these gases can directly interact with the water vapor that is there, and they can be dissolved on the top layer. And because they are acidic in nature, they will try to reduce the pH. So, pH of the water will reduce, and this is all this process is called ocean acidification. Okay. So, this is very important. I mean, this is a very busy slide, and I think I discussed many of the things, and then of course, I talked about this their impact on the ocean and biogeochemistry they will impact. So, some of the key nutrients that are there, nitrogen is of course there, and this is actually in the form of either in the form of ammonium, nitrate or nitric acid usually, and then you can also say in the form of this one. So, there could be also ammonium sulfate also could be there, NH4 whole twice, and this can also be NH4 NH3 nitrate form will be there, or you can have ammonium H SO4. Okay. So, this also ammonium bisulfate you can have. So, this is different form. Actually, these are in most of the cases part of this will be actually in this form directly in the nitrate form, water soluble form, and most of them will be in the form of some compounds. Okay. They will not be directly available as a in the form of ions. Okay. The sources are agriculture, fossil fuel combustion and natural emission, but this is not like that. This is not very easy process. This agriculture, for example, agriculture will produce ammonia, and this ammonia will be converted to here. Then you have any species that is producing NOx, it will be giving rise to the nitrate and HNO3 radicals. So, basically for example, any ammonia, except this process NH3 to ammonia, this process is what you call reduction. This only this process reduce is a reduction. Other process are actually most of the process are oxidation. So, only I think there are not much reduction processes or reduction reactions. The only reactions are the only among the few reduction reactions converting ammonia gas into ammonium particulate form is actually a kind of reduction. Okay. So, they are actually in the agriculture, they are not directly emitted in the form of particulate matter, they are emitted as a gas, and then the process is called gas to particle conversion. Okay. So, this is also called GPC, gas to particle conversion. This is actually lots of things that are there. This will happen because of the secondary processes. Okay, secondary reaction process or secondary atmospheric reaction processes, whatever you want to say here. So, this will happen, and then they are actually, what is their importance? They are very important for plant growth and ocean phytoplankton. So, this is really very important. So, we should always give an importance. This is actually for example, even in the lands, some lands are actually nitrogen deficient, and especially in the, for example, Himalayas. So, there the deposition becomes very important source. Okay. We have a paper on this one. So, if you are interested, this paper is actually in ESNT, Environmental Science and Technology. I think it was published in 2022 or 2023. So, we discussed about the impact of wildfire on production of this nitrogen species. So, the second one is actually phosphorus. Phosphorus is again very important. So, this is mostly in the form of phosphate minerals or dissolved phosphate, like I talk about phosphate ions. Then what are the sources? Source are actually either soil dust or biomass burning. They are majorly of the sources, because phosphate is associated with the minerals, so it is associated with the soil, and dissolved form can come from the biomass burning, because it already contained oxidative group. So, it could be actually converted into this one. They are very important for DNA, RNA and energy transfer in living organisms. So, you can see the importance of phosphorus, it is really very important source. Then we have other source like nitrogen, iron, sulfur, potassium, calcium and magnesium. These are actually very much needed for this one. So, in the next slide we have like iron. Iron, as we know, in the aerosols it will be either in the form of hematite or ferric oxide or dissolved iron. This is if you just go back to dissolved iron process, I just talked about here. If you just pay attention to this one, this one. So, suppose this aerosols base contained some form of iron. So, this iron could be either in the form of Fe+2 or Fe+3, it could be both the form. And when this actually process will take place, this iron, which is actually even not labile or not available as the to taken up by the plants, this can be released and this iron can be converted into the ionic form. So, this is very important. Okay. So, for example, you have hematite and ferric oxide, they can be converted into these two in the atmospheric processes, they can be converted into Fe3 or Fe2 form. Okay. So, when they are converted, they becomes directly accessible. Okay. And then desert dust and volcanic eruption, they are the major sources, and there are studies which suggest that this is also called bioavailable iron, because it is directly available to this one, and then they actually are in the form of dissolved iron. This is very actually important, and there is a very famous reaction that is associated with this one, is called Fenton reaction, which helps in dissolution of the iron and getting it to in the labile form or bioavailable form. The importance is, they are very important for marine phytoplankton and nitrogen fixation. So, this is again really very important. Then sulfur are usually in the form of sulfate and sulfur dioxide. Something you can also talk about, like it could be in the form of sulfur gaseous or liquid form, and then I talked about like sulfate usually will be in the form of I discussed this one, that it could be in the form of either ammonium sulfate, ammonium nitrate or ammonium bisulfate. there are actually stoichiometrically you can calculate that which form is prevalent. Maybe in the next in few lectures on atmospheric chemistry I will be discussing on this one as well. So, this is again, and then what are the sources? Sources are volcanoes, fossil fuel combustion. So, this is fossil fuel combustion, especially coal and diesel vehicles. They are highly producing sulfur in this one, because coal contains sulfur that can be oxidized, and similarly diesel also. So, these are the fossil fuel combustion can produce this one, and then through the process of volcanic sulfur dioxide is released along with the ashes. The impact there are very important for the cloud formation and acid rain. This is very important. So, this one is actually directly very important, because when the rain will happen, the water will come, is actually in contact with CO2, it will give H2CO3 bicarbonic acid, but it is in equilibrium actually. So, hot pH of the rainwater will be depend on the CO2 concentration primarily, but at the same time if you are adding here H2SO4, what will happen? This will lead to decrease in pH, or if you are adding HNO3 in the and then in the water, this process will lead to a reduction in the pH, and this means this will be water will be your more acidic. Okay. Then so this will be actually called as a acid rain. Generally pH less than 5.5 is called acid rain. So, if the pH of the rainwater reduces to as low as less than 5.5, it is usually called as acidic rain. Then there are few key elements further: potassium, calcium and magnesium. Their main source are soil dust and sea spray. So, calcium, magnesium are very important. I discussed in the previous slides. They are the main composition of the dust. So, they can come from the dust or sea spray. The essential micronutrients for the plants and organisms, they are very important. And I also discussed, because this potassium when the plants are actually burned or when the plants die, what will happen? And if you just burn this, it will produce potassium in the form of K plus, and this K plus in aerosols. So, if you are getting high concentration of K plus, this implies that you are actually having increased biomass burning emission. So, the source of aerosols can be used to identify this one, but at the same time plants are also needing, actually plants need, and because the plants will take these nutrients through the water, from the root they will take water and they will form this. So, this is very important for the plant growth. So, I think I should skip this one. I have been discussing so much of the about the sources. I talked about this anthropogenic and dust sources. Yeah, we talked about mostly on this one: volcanic eruptions, sea spray aerosols, rich in salt and organic matter, dust storm. This is actually transport mineral like iron and phosphorus. They are very important for this one. And then of course calcium can be there, magnesium can be there, and potassium can be there. They are very important source for this. Then there are anthropogenic sources. They are actually increasing this one. For example, industrial emission. They put lots of micronutrients in the atmosphere. So, in a way, actually, it is not that the industries are bad only. They are good for, they are putting some of the nutrients. But when you calculate the net, the loss because of the industrial emission is much more than the what you call positive sides of this one. So, that is very important. Then we have agriculture fertilizers. For example, we use urea, which is NH2, CO NH2. This is CO means carbon, CO, not cobalt, carbon and oxygen, and this is actually where used, then they will produce ammonia from here, ammonia gas. And if this urea is actually dissolved in water, because what will happen? Plant will not take 100%. Okay, plant will not take 100% of urea. They will take only few percent of this one, and because the farmers are not knowledgeable, they don't know that how much iron they how much urea is needed, they just only see the color, look at the color of the plants. If it is green, oh, this is okay, the plant growth is okay, photosynthesis is good. But what happens sometimes, or most of the time, they put excess of urea. When they put excess of urea, what will happen? This excess urea is not taken up by the plants. So, when the plants are not taking this one, this urea will remain in the soil. Okay? And when when they will be doing the watering, or through the watering process, or simply rainfall, they will be actually dissolved, and they will go into dissolved in this one, they can reach into the soil, and from soil they can penetrate into the deep into the groundwater even. So, this is very important, and if they are actually not this one, majority of this one actually as a surface water, they will be transported to river, ponds, or something like that. So, aquatic bodies mainly. So, when they are transported to aquatic bodies, they will actually give nutrients to there. So, that is also another very important thing, but this pollution is becoming very important. We will discuss this one. Nitrate and sulfur pollution in groundwater is becoming a very big issue nowadays. Mostly produced by agricultural activities, or they are in some combustion processes. Then, for example, agricultural waste burning and other things. This toxicity will not discuss in these slides, and then So, then the next thing is that how much is actually acidic species like HNO3 and H2SO4 they are impacting. So, mostly this when we say sulfuric acid, for example, you see here sulfuric acid, this is derived from the oxidation of sulfur oxide that has been discussing by the volcanic eruption or fossil fuel combustion or any industrial process. Okay. They are major contributor to the acid rain, they affect cloud formation and atmospheric pH. Atmospheric pH as well as rainwater pH, they affect this one. So, this is very important, and because I am not going to discuss much details of this one, there even can be a series of lectures on this one, at least couple of lectures can be there on acid rain. I gave very brief idea about this one. We will be discussing about the cloud formation slightly. I am not sure if we are going to discuss this one because it involves lots of chemistry, and then master's students may be bored. So, undergraduate students might be bored. So, we have to take a balance between UG and PG students as well as PhD and then other industry researcher or industry kind of officials. Then we have nitric acid. This is produced by reaction of nitric acid and nitrogen oxide NOx with hydroxyl radical in the atmosphere. This is very important. So, I will give the example of OH radical, how this OH radical is actually using this conversion of this process. They are mostly produced by the vehicles, power plants and biomass burning. These are the three major important sources of NOx, and therefore, they are major sources of HNO3, because HNO3 will directly not be coming into the atmosphere as HNO3 gases. So, little bit about the HCl. This is although very less, but this is actually released from the sea salt spray or industrial process. And this sea salt, how will you know that this is coming from this one? So, usually there is actually chloride enrichment. So, because this means that we are adding chloride from some other sources, and which could not be there actually. So, for example, if you are very close to sea, then this chloride could be actually coming from here, but if it is chloride is coming, if you are not, there is no sea, the most likely source will be industrial process or biomass burning also gives some of the form of chloride actually, not directly HCl, but chloride is coming from there. So, this comes from the chloride containing compounds, combustion of this one, you can see here. So, basically this plastics and other things they can give rise to this one. This acidifies aerosols, impact air sea exchange of gases. So, I talked about this one, and this reaction is very important actually, and this is also sometimes can contribute even to the dissolution of other particulate matter that are there in the atmosphere. Then the other things are like very small, but they are actually very important. Formic acid and acetic acid, organic acids, they are directly coming from the vegetation through secondary organic aerosol formation processes. I have not discussed this one, but we will discuss this one. And then they could be biogenic, biomass burning or industrial activities. They influence the acidity because they are actually acids, so they can influence the acidity or pH. This means they usually will reduce pH. Okay, so as you know, they will reduce the pH. And then hygroscopicity of the aerosols, the capacity of aerosols to attract water and hold water on their surfaces, hygroscopicity. We will discuss during the aerosol cloud interaction, all those things. Then ammonium bisulfate, I think I have already discussed interaction of sulfuric acid with ammonia. So part of this one can be prepared. Buffer acidity, buffers aerosol acidity, but still contribute to the acid rain. So this is very important source that this sulfuric acid will be produced and they will be contributing to the acidic rain. I don't know, yeah. So let me just give you now. After discussing this one, as you must have known, on a global scale, mineral dust acts as a reactive surface of atmospheric reaction. This is very important. In the very first slide, I talked about the reactive processes that can be there on the dust surface. And via this, it adds actually micronutrients like reactive nitrogen, basically the soluble nitrogen, and then micronutrients like iron, nutrients to the ocean, and which leads to the high productivity and can significantly modulate nitrogen and carbon cycle. Okay, so this is this process. There are lots of papers on this one, and people are still trying to understand this. Not only that, this will also affect the radiative properties, because they will be, once the this aerosols reactive surface are change their surface properties, the optical properties will change, and because of that one, radiative properties will change. So we will discuss this again in the next lecture. They impact air quality and affect visibility, of course, because they are hygroscopic are there, then they can lead to increase in the size, particle size. They affect human health as well as ocean ecosystem. So their effect actually is studied on the human as well, but not micronutrients here, like here we discuss mostly on the nitrate, phosphate, sulfate, and then acids that are there, but not micronutrients like iron. So iron, for example, we also need iron for what our body contains lots of blood, and that blood needs to be circulated. This iron is very important. So hemoglobin, in the form of hemoglobin. So this is important there. Then we have a ocean ecosystem. They are really very important for the ocean ecosystem process. So to summarize, aeolian dust and their ocean biogeochemistry and climate, they are actually kind of interlinked. So you have aeolian dust loading. You see the red one is actually containing lots of dust. These are the areas where the dust are higher, other places dust is not high. This supplies iron and reactive nitrogen supply. So because of this one, this can contribute to the marine productivity, nitrogen fixation and denitrification processes as well. So these three processes can be affected by the supply of aeolian dust, and especially the iron and nutrient cycle. And once they are actually there could be a bi-directional relationship between the marine productivity and climatic state. N2O and CH4 emission increase positive radiative forcing. So this will, when there is a more marine productivity, what will happen? CO2 will be consumed. So CO2 concentration will decrease, means there will be CO2 sequestration. CO2 will be sequestered from the atmosphere. This will decrease the positive radiative forcing that is caused by carbon dioxide as a greenhouse gas. So this will reduce, and this will also, when you have kind of cooling or negative positive radiative forcing is reduced, then sea surface temperature and ocean circulation can be affected. This is another very important thing. And if these are affected, the climate state of the ocean is affected, and because of that one, N2O and CH4 emissions can be affected, and this lead to increase in the more increase in gases like N2O and CH4, which will lead to a positive radiative forcing. Not only that, radiative, I discussed that one, this climate state and aerosols, they are also affecting the radiative forcing as well as CCN population, cloud condensation nuclei we have discussed. We will discuss more in the aerosol cloud interaction. They will affect the precipitation, dust emission and transport. So, all the processes, if you see it is not just one way process of these micronutrients deposition to the ocean. There will be another processes that will be affecting the feedback mechanisms are there, that because of this one the climate can change, the sea surface temperature can change, ocean circulation even can change, and then there will be a changes in the N2O and CH4 emissions from this one. Carbon dioxide will be sequestered, the CCN properties of the clouds and radiative properties will change. So, to sum up together, this is a very important thing that we need to understand this aeolian dust and ocean biogeochemistry and climate. So, with this one I stop this lecture. I thank you for attending and patiently listening me. I think if you have any question, comments or suggestion, please do write to me. You can always ask. There will be TAs who will be helping you in this session. If you are not able to understand, please ask us. We will try to give you proper answer to this, to your questions, and then this lecture will be very important for futures coming lectures. So try to understand this impact, the impact of the aerosols on the ocean biogeochemistry, or the through the input of micronutrients and then reactive nitrogen species. So thank you so much. Take care and bye bye.